Hello friend, this is Rupesh and I'm watching C Beginners video series on C++ and today's topic is use of join, detach and joinable in C++ thread. So if you're following my video series on thread, you might be seeing me using this join, but I did not explain this much. So today we'll see join and its counterpart detach and what is the use of this joinable here. So let's look at the join nodes first. It says that once a thread is started, we wait for this thread to finish by calling join function on that thread object. So let's write a program to understand this line here. So if you are writing a thread, you need a callable object. So I can say that, okay, run. And this is your function. And this will just simply print Rupesh, okay, CPP nuts. And not only this, let's do something else. Let's take some count here. While count tends to 0, we'll print this. Okay, so this is what your thread will look like. And now let's create a thread. So std thread t1, and here you will pass run and how many times you want to print. Let's make it 10 here, and this is what the join is. Okay, so let's save this, compile and run. So compiled it, successfully compiled. If I will execute it, this will print this CPP nuts for 10 times. Okay, that's it, no problem. So let's try to understand this join here. As I said, once a thread is started, we wait for this thread to finish by calling join function on that thread object. So what we are doing is, as soon as you create a thread object by passing function and the parameter, if you want to pass any parameter, it will create a thread and it will start running that thread and the control will come back here. So let's see that. Let's print something here. Let's print main here, main function. Okay, and this thread is not a very big time taking thread. So what I will do, I will make this thread on waiting state so that we can assume that, okay, it is taking some 3 seconds or 4 seconds. So std this, thread, sleep for, I keep changing my keyboard, so this is not working, chrono seconds. Let's make it sleep for 3 seconds. So what it will do, thread will start here, it will come, it will do its job, and then it is sleeping for 3 seconds, and we are simulating that this thread will do some job which will take 3 seconds. So I'm putting this thread on sleep, but don't think that it is sleeping. We are simulating the behavior that it is taking some 3 seconds to complete some task. Okay, so that we can see that it will actually wait here. I mean, your main thread will wait for this thread here and it will not go further. Okay, so we can simply print main after. Okay, let's save this, compile this and execute this. See, main came. Okay, did you see that? It was waiting for 3 seconds, then only it printed main after. Okay, so it was waiting here. I can show you again. Let's clear this. I will run this. See, it is waiting. Okay, now it has come. Can you see that? So what happened? T1 is a thread. It started this run as a thread and it came back, printed main. By the time this thread is starting, because it is taking a little bit of time, because thread is created using OS, so OS is taking a little bit of time to start this thread. By that time, your main is back. After saying to the OS that, okay, you start this as a thread, your main thread is back, printed this main. Can you see that? First it is printing main. After printing main, it is getting that, okay, t1.join. It means I have to wait for this t1, which is this thread. But this thread will take at least 3 seconds. After printing these 10 times, it will take 3 seconds. Then only after this, it is printing this one. Okay, So this is the job of join. The moment your program hit the join on some thread object, it will wait there for that thread to be completed. Now you might be thinking, what if I want to go further? Yeah, that is the answer which comes with detach here. Okay. So this was the first point. I think you might have understood. Let's give some 5 seconds. I know it's clear, but still, I have compiled, executed. See, we are waiting for 5 seconds. Yeah, then only it is printing main after. So we are waiting here for this thread, and this thread was doing some great job which took 5 seconds. So this was the first point. Now let's move to the second point. Double join will result into program termination. Okay. What if I write join 2 times? Let's see that. It will not give you a compile time error because syntax and semantics and everything is correct. If you will run this, see, terminate called after throwing an instance of system error, invalid argument, whatever it is saying that 2-time join is not allowed. And it doesn't make any sense because you waited for this thread to be completed at this line. Now again you are waiting for this thread to be completed because you're writing it, and it doesn't make any sense because that was completed before itself. Okay, because you came out from this because it was completed, and again you are waiting for this to be completed, which doesn't make any sense. That's why it's an error and it's a crash. So always remember that you should not double join. And third point is related to that only. If needed, we should check thread is joinable before joining using joinable function. Yes, actually what happens, sometimes you write this t1.join and after this you're writing so much of code. Okay, here maybe 300-400 lines of code, and after that maybe you happen to rejoin it. You don't remember that, okay, I joined it before itself. So the best practice is, before actually joining, what you should do is you should check if this t1 dot is joinable. If yes, then only you should join. Okay, so let's compile this. Let me just give some little indentation here. Okay, compile and execute. This time it should not fail. See, it didn't fail. Okay, even if you are written it, it is not going there because this thread is no more joinable. This is the use of joinable function. So I think you understood this point also, that you should always apply joinable before actually joining your thread. And if you are writing very small program where you are sure that it is not joined before, or you are not writing any complex program where you may end up joining again and again, then in that case you can omit this. Okay, so let's move to the detach nodes, which says that this is used to detach newly created thread from the parent thread. Okay, what is parent thread here? This main thread. Okay, let me remind you, whenever you write a single threaded program, not using any thread, it is a single threaded program, okay, which is a single process also. So when you create some thread like this one you created here, so this thread will become the parent thread for this one. Okay, so that's what I'm saying here. This is used to detach newly created thread from the parent thread. Okay, we were joining, now we were waiting for that. Let's not wait for that. So let me remove all this extra stuff. And if I will put this detach here, then what will happen? Let's see. And to demonstrate it a little better, let's have this count also, so that we can see how many times it is taking it. I think it should be taking very fast, but still let's give it a try. Okay, 920 main after. Can you see this program was completed and it didn't wait for 5 seconds. Can you see we had this 5 seconds before, and when we were waiting for this thread to complete, it was waiting. Let me just run this again. See, it completed. Okay, it is messing up now, but that's okay. This much behavior is acceptable in threading. You don't know what will start first, okay? But one thing is sure, that you're not waiting for this thread to complete. See, it terminated right away. And to show you that, let's print something else. thread finished. Okay, so if I will compile this, run this, okay, this is some different output. Okay, so let's try to understand why this is coming. So it will clear up your few doubts. See, what happened when you created this thread T1, what happened? The request goes to OS. OS takes some time to create a thread and take this function and create this function as a thread, and then control will come back to this main thread, and this is also running and this is also running, correct? Then you will print this one and OS will run this thread. But the time taken by OS was little bit more than printing these two line on the console, and your main thread was returned before actually OS can start this thread. That's what happened here. Because you have detached your thread, you're not saying that wait for this thread to complete. You're saying detach this thread from this main thread. I no longer want to wait for this thread. That's why you're not waiting for this thread and you don't care whether it is running or not. So this is a really nice example. Okay, so if I will run this again, something else might come. Let's see. No. Okay, why no? Okay, before, did you notice this came and after that nothing is coming? So this is totally unexpected, but actually it is expected. It's okay. Actually your OS is taking a little bit of time for this. Before that you are actually terminating yourself, and if you want to be sure for that, let's play some game here. What can I do here? Okay, let's take this one and place it here or here. Okay, and comment this and recompile and execute. Yay! See, now you're waiting. Okay, so now understand this behavior. What happened? You created thread. It was, the request was gone to the OS and your control was back. You printed this main here, and after that you said, okay, I am detaching this thread from main. That's okay. Till then, actually OS didn't started this because we have not printed anything from here. So after detaching, your main thread is printing main after. Till that time, OS could not start this thread because OS is little bit slow as compared to printing these two lines. And after printing this, you are waiting. You are sleeping. So your main thread is sleeping. By that time, 5 seconds is really very big number for OS to start a thread. So OS started this thread and everything was completed, and this thread finished, was executed, and your wait is finished, and then you are returning from here. So let's execute this again. See, you are waiting here for 5 seconds on this thread, main thread, and then you're done. Okay, so let's comment this and compile this and run this again. See, it is still giving you that output. And let me repeat this. T1 started means you said to the OS, okay, I want to start this as a thread. OS will take that request, okay, process it, okay, will understand, okay, I have to make some resources for this thread to be started. By that time your control of main thread is back. So you're printing this main to the console. By that time OS is doing its job to start this thread actually, and then you did this t1.detach. Still OS is processing this thread, didn't started it yet, and then you happen to print this also, but still OS is busy doing something, could not start it, and lastly you hit this return 0. So you are gone from this main and OS could not start this. So that's why you're not getting any output from this thread. And yes, if you are detaching some thread and your main function is returned, completed, your program is terminated, this thread will no longer available. It will be suspended. Okay? Because OS keep track that, okay, from where this thread is coming. Even if you have detached it, OS will know that which one is the parent. So if parent goes, all the child goes automatically. And maybe that's the point here. If we have detached thread and main function is returning, then the detached thread execution is suspended. And the main point was always check before detaching a thread that it is joinable, otherwise we may end up double detaching. Yeah, that's the same problem of double join. We have the same problem with the double detach also, because you may write t1 dot detach, and let's compile this and run this. See, it is again a crash. It is aborting your program. So double detach is also a problem. So the simple solution for this is yes, you will use joinable. So if t1 dot joinable, then only you detach. And it makes sense, right? If you can join, if this thread is joinable, then only you will detach it. So let's compile this, execute this. Okay, no problem. So all these points are over. Now lastly, let's look at this point. Either join or detach should be called on thread object, otherwise during thread object's destructor it will terminate the program, because inside destructor it checks if thread is still joinable. If yes, then it terminates the program. So remember, whenever you are creating some thread like this, either you should write detach or join. You should not just keep it like this. No, this is a problem. Why problem? Because in T1's destructor, it will check whether this thread is joinable or not. And if this thread is joinable, it will terminate that at the moment only. Okay. So this is very bad if you're not writing any join or detach. So remember, either you have to write join or detach if you are creating thread. So let's complete this video. Thanks for watching. If you like the video, don't forget to hit the like button, dude. It will help me a lot. And if you have any suggestion, or if I forgot something to mention here, please let me know in the comment section. It will be very helpful for others to know the topic more detailed, and we'll learn together. So I'll see you in the next video. Bye bye.